What is an isotope? An isotope is two or more forms of the same element that have equal numbers of protons but different numbers of neutrons. So how do we name isotopes? You take the element name and put a hyphen between that and the isotope's mass number. The mass number is equal to the number of protons plus the number of neutrons in that atom. Let's take carbon for example. Carbon has an atomic number of 6, which means it has 6 protons, and a mass number of 12, which is equal to the number of protons plus the number of neutrons. Remember, the mass number that you see on the periodic table is an average of the mass numbers of all of the element's isotopes, taking into consideration how abundant they are. Let's look at 3 common isotopes of carbon: carbon-12, carbon-13, and carbon-14. Every carbon isotope has 6 protons, and to find the number of neutrons, you take the mass number minus the number of protons to get the number of neutrons. So carbon-12, you have 6 neutrons. In carbon-13, you'll take 13 minus 6, and you'll end up with 7 neutrons. And in carbon-14, you'll take 14 minus 6 and end up with 8 neutrons. Carbon-14, however, is a radioactive isotope. A radioactive isotope is an isotope whose nucleus is unstable and dissipates excess energy by spontaneously emitting radiation in the form of alpha, beta, and gamma rays. Radioactive isotopes decompose to reach a more stable state in a process called radioactive decay. Now we're going to go through some practice problems to find the number of protons and neutrons in an isotope. The symbol you see written here has atomic symbol, with mass number at the top and atomic number at the bottom. It can also be written without the atomic number. If you want to give it a try yourself, pause the video now or keep watching for a demonstration. In this example, sodium has 11 protons, and to find the number of neutrons, you take the mass number minus protons to get 13 neutrons. In this example, the number of neutrons is given, and you can find protons from the atomic number. To find the mass number, you add protons and neutrons to get 241. In the final example, the number of protons gives you the atomic number, and to find the number of neutrons, you subtract protons from the mass number to get 143. Now we will look at finding average atomic mass using percent abundance. First, you take the exact weight of the isotope times the percent abundance as a decimal. Do this for all available isotopes and add them together to find average atomic mass. In this case, it is 12 times 0.9890 plus 13.003355 times 0.0110 to give you 12.011 atomic mass units. If you want some practice on your own, now would be a good time to pause the video. Otherwise, just keep watching for a demonstration. In this case, you'll take the exact weight of silicon-28 times 0.9223 plus the exact weight of silicon-29 times 0.0467 plus the exact weight of silicon-30 times 0.0310 to give you 28.086 atomic mass units.